Okay, before we get into this notes, I just wanted to show you this little example that I came up with. Let's say you have a $5 bill. Okay, that $5 bill is equal to two $1 bills plus three $1 bills, right? Because 5 equals 2 plus 3. Okay. Well, if I was to take away, let's say, the $2, well, wouldn't it be safe to assume that that my $5 bill now is still more than what I had originally, right? So that's more than $3. Okay, and the same thing's true if I was to take away the $3 bill, right? And I could say pretty safely, hey, this $5 bill has got to be more than $2. Oops, because I could put a 2 to show $2. Right? So that's really all this property is going to say that we're going to learn on the next slide. So here we go, 5.2, inequalities in triangles. Students will be able to use inequalities involving the angles of sides of triangles by completing problems as taught. So this is just a comparison inequality. So look here, I said if A equals B plus C, well, A would be like my $5, B like my $2, and C like my $3. And as long as C is greater than 0, as long as C is positive, then we know that A has to be greater than B. And we also know that A has to be greater than C as well, right? As long as these two things are positive. And when we're dealing with angles of triangles, they're always positive. We don't have negative angles. So let's do a quick little proof. First off, C is greater than 0. How do I know that? Well, it's given. In fact, I'll just do this. This is my given, because that's the if statement. And then this is my thing that I'm trying to prove. Okay? Then A is greater than B. So yeah, let's go ahead and do this. Yeah, C is greater than 0. Well, that's part of my if statement, so that's part of my given. And then what did I do to both sides of the equation here? I had C is greater than 0, and now I have B plus C and B plus 0. Well, I added B to both sides. That's it. So that's just the addition property. And we can still say addition property of equality. It's fine for now. So yeah, that's all I did. And now that's the same thing as B plus C is greater than B, because B plus 0 is the same thing as B, right? That's called the additive identity. Anything plus 0 just equals itself. Okay, well, now I have A equals B plus C. Where did I get that from? Well, look, that was part of my given as well, so let's throw that in there. And lastly, what can I do? Well, we know what we're trying to prove, and it's our last step. But look, I have A equals B plus C, and here I have a B plus C. So couldn't I just take this A and plug it in for anywhere I have a B plus C and rewrite it as A is greater than B? And all I really did there was I substituted in, so I could say substitution property of equality. There we go. So we proved it, that in fact, given two things, B plus C, and they're equal to A, that as long as C is positive, then we could say A is always going to be greater than B. Okay? And that's going to help us in comparing sides of triangles and angles of triangles. But before we do that, I want you to go ahead and see if you can recall the triangle exterior angle theorem. If you need to pause the video, go back and look at some notes, but you're going to need to remember that in order to keep going. So go ahead and pause the video, see if you can remember what that is, and I'll remind you in just a second. Well, hopefully you remembered. The exterior angle theorem said, hey, if I have two angles on the interior of a triangle, so 2 and 3, they'd be equal to the exterior angle that's not touching either one of those two angles. So we could say 2 plus 3 will always equal angle 1 right here. Angle 2 plus 3 equals angle 1. So that's what it would say, and we'll just write that right here. We could say, okay, angle 2 plus angle 3 equal angle 1. Now, maybe I should have called this angle 5, because that would make a little bit more sense, right? Angle 2 plus 3 equals angle 5. But really, these aren't measurements. These are just names, so it's okay. And this is kind of like our $5 bill scenario, right? So this would be like our $5 bill, and this would be like our $3, this would be like our $2. And so we know together they're equal to angle 1. But if I was to separate them, I would know for certain angle 1 has to be greater than angle 2, and angle 1 has to be greater than angle 3. And that's just a corollary. That's the corollary to the triangle exterior angle theorem. That's all we're saying is, hey, if these two things add together equal this angle out here, then that means that that angle out there has to be greater than those angles when they're all by themselves. That's easy. Alright, what I want you to do is I want you to take that into consideration and see if you could figure out a good explanation as to why you know that measurement of OTY, so this angle right here, is greater than the measurement of angle 3. You don't have to write a formal proof, but just see if you can give me enough information as to why that is. Think about it for a little bit, pause the video, and then I'll explain in a second. Okay, hopefully you've already thought about it, and this is what I wanted you to see. One, we have two interior angles here, 3 and 4, and angle 1 is an exterior angle. So we know that 3 plus 4 equals 1. And we also know that angle 3 has to be less than angle 1, and angle 4 has to be less than angle 1. So we could write a little thing there. We could just say, hey, angle 3, write it over here, is definitely less than angle 1. That's what we learned in this theorem right here. We know that because it's an interior angle and that's an exterior angle, and so we know it's going to be less than it. Okay. Well, what else do we know? We also know that 1 and 2 are the base angles of an isosceles triangle, right? Because these two sides are congruent. So these two angles here are congruent. So we could say that. We could say, hey, we know that angle 1 is the same thing as angle 2. And if that's true, then we could substitute this in. We could say, hey, angle 3 has to be less than angle 2 as well, because 1 and 2 are equal. Alright, so we're getting a little bit closer, because now we have some type of comparison between angle 3 and angle 2, but we wanted a comparison between OTY. Well, let's go over here, let's do this part in red. We know that angle 4 plus angle 2 equals angle OTY. And so by the comparison property of equality that we learned earlier, we also know that angle 2 all by itself has to be less than angle OTY. Well, look, now we have a little bridge here. We could say, hey, angle 3 is less than angle 2, and angle 2 is less than angle OTY. Therefore, angle 3 has to be less than. My less thans and my angles look a little bit alike. I'm sorry about that. Here, try and make it a little bit better. Less than angle OTY. Or maybe I'll make my little therefore symbol right there. Alright, so it's not a formal proof, but we're just kind of explaining our logic and how we know that this is absolutely true. And you could have explained it a little bit differently, and that's probably okay. But you probably need some system going from 3 to 1, 1 to 2, 3 to 2, and then showing me that 2 is less than OTY, therefore 3 is less than OTY. But there might be another way to do it, and I'd be open to hear it. If you did another way, tell me in class. Alright, this last part is a pretty simple part, but for whatever reason, kids get a little bit confused on this one. But all these two theorems are saying, well, let's read them first and let me explain it. It says, if two sides of a triangle are not congruent, so it's just a scalene triangle, then the larger angle lies opposite the longer side. So if this is the largest angle, and this is the largest side, they should be opposite of each other. And theorem 510 is just its converse. It says if two angles of a triangle are not congruent, then the longer side lies opposite the longer angle. So, same thing, longer side, opposite the larger angle. That also means that the smallest angle lies opposite the smallest side, and the middle angle lies opposite the middle side. So we can really easily write a system of comparisons, and we could say, hey, we know that angle A has got to be greater than angle B, which has got to be greater than angle C. We could just tell because we could look at the lengths of the sides here. And usually they'll give us numbers, but I just kind of want you to see it. And we also know, we can know the lengths of the sides. We know the order of the sides, right? We know that BC is greater than AC, which is greater than AB. And I want to show you something else in a triangle. Maybe you already saw this, but look, when I'm talking about angle A, the side opposite of angle A is BC. It's the two letters not included in this angle. And the same thing, angle A is the one letter not included in this side. So here we have angle A, side BC. And here we have angle B, side AC. Here we have angle C, side AB. So even if I didn't give you a drawing, and I was to just tell you, hey, there's triangle, there's triangle, like, let's do it in blue. There exists triangle PQR. You should be able to tell me what angle is opposite, or what side's opposite angle R, angle P, and angle Q, without even drawing it out. And here's how you can do it. Well, what two letters are not included in R? P and Q, right? So we know its opposite side is PQ. Same thing with P. Two letters not included with P are Q and R, and two letters not included in Q are PR. Alright, there you go. That's all of 5.2. Yeah. See you guys after break.